Pankti's tutorial. This video lecture would be about the first classification of a system, that is linear and non-linear systems. Consider we have a system that takes input as x of t and gives output as y of t. The same system can be represented as x of t. When it passes through the system, it becomes y of t, and this is a more simpler way of representing the system. I'll be using this kind of a statement now on. For a system to be linear, it must satisfy this equation. This equation actually consists of two principles. I'll explain each of the principles to you one by one. The first principle is, suppose we have the signal as x of t, and when we pass it through the system, we get the output as y of t. If this signal is multiplied by a factor or constant which is a, and then is given to the same system, then the output should also be multiplied by the same factor, and this principle is called as the homogeneity principle. To explain to you the second principle, I am considering two signals. The first signal is x1 of t. When it is passed through the system, it gives the output as y1 of t. The second signal is x2 of t, which when passed through the same system would give the output as y2 of t. Now what I am doing is, when I am taking the sum of these two signals at the input side, the output that I should get should be sum of the earlier individual output, and this property is called as superposition property or additivity property. If a system is satisfying both homogeneity principle and superposition principle, then it is called as a linear system. If it fails to satisfy any one of these principles, then it is a non-linear system. So in this statement, what is shown is the two input signals are multiplied with two different constants. At the output side also, their outputs are getting multiplied with the same constant. This is to show the homogeneity principle. At the input side, we have superimposed the two signals by this plus sign, and at the output side also, we are getting the output as the sum of the individual outputs. This is to show the superposition principle. So when a system is a linear system, it should satisfy this equation. That means it should satisfy both the principles. If a system is satisfying both homogeneity principle and superposition principle, then it is called as a linear system. If it fails to satisfy any one of these principles, then it is a non-linear system. Let us try and understand this more clearly with some examples. Now the system that I have is giving me the output 2xt. That would mean when xt is passed through the system, it is getting transformed to 2xt. So it will be written as so this is the equation that we will be getting. Now to check whether the system is linear or non-linear, what I will be doing is I will be testing it for homogeneity and superposition one by one. So to check for homogeneity, what I have done is I have multiplied xt with a constant a. When I have passed it through the system, the output where we had xt now will have axt. So at the place where I had xt, I have written here as axt. Now a, since it is a constant, it can be taken out. So a is here now, and the multiplication factor is 2xt. This 2xt is equal to my yt. So I have substituted here yt. This is giving me a relation when xt, or when the input signal is getting multiplied with a constant, the output signal is also getting multiplied with the same constant. Therefore, for this system, the homogeneity principle is verified. The second task is to verify the superposition principle. So for verifying the superposition principle, what I have done is I have taken two signals, x1t and x2t. When x1t is passed through the system, it is giving the output as 2 of x1t, which is then equal to y1t. When x2t is passed through the system, it is giving the output as 2x2t, which is then equal to y2t. Now to verify the superposition principle, what I have to do is I have to give the input as sum of the two signals. So I am giving the input as sum of the two signals. Where we had a single signal here, then I have to substitute the sum here at the output side. So at the output side where we had a single signal, there I have substituted it as sum of two signals. When we open up this bracket, it becomes twice of x1t plus twice of x2t. Now this twice of x1t is equal to y1t, so I'm replacing here with y1t. This twice of x2t is equal to y2t, so here I'm replacing it with y2t. What do we notice here is the output that I'm getting here is actually the sum of two individual outputs that we had. So this is then verifying the superposition principle also. Since it is verifying both homogeneity and superposition principle, therefore this system will be a linear system. The next system that I have is a system whose output is yt is equal to 2xt plus 3. That would mean when signal xt passes through the system, the output that we are getting is 2xt plus 3. Now to check whether the system is linear or non-linear, we'll be again performing the tests on homogeneity and superposition principles. Now to check for homogeneity, what I have done is I have multiplied the signal with a constant a. When this signal is then passed through the system, the place where we had x, they will be substituting it as axt. So here I have substituted it as axt. So the resultant signal that we are getting is 2axt plus 3. Now this is not equal to a into yt, because a into yt would be equal to a multiplied with 2xt plus 3. Since this system is failing at the homogeneity principle, therefore it will be a non-linear system. Now the next system that I have is a system which is equal to yt equal to e raised to the power xt. That would mean when xt is passed through the system, it goes to the power of the exponent. So here it becomes e raised to the power xt. Again, to check for the linearity and non-linearity of this system, we have to check it on homogeneity principle and superposition principle. So let's apply them one by one. Now when we are checking it for homogeneity, again what do? Is we multiply xt with a constant a. When I pass it through the system, the place where we had xt, now I will substitute it as axt. So the result that I am getting is e raised to the power axt. Now this is not equal to a multiplied with yt, because a multiplied with yt will be of this form. Since the homogeneity principle is failing here, therefore this system will also be a non-linear system. I hope these examples are enough to explain to you how the linearity and non-linearity of a system is checked.